everyone. Thank you for watching this. Thank you for joining this, and thank you for watching all the rest of the days that we documented. This is day 20 today, so we've been doing this for 20 days. This is awesome. We will keep learning and see where we could take that destruction as we are joining DoubleJump Academy's workshop, Houdini for Games in Unreal. The link is in the description if you're curious how that looks like and the price and everything else. Yeah, we are taking that destruction a step further in the optimization. Last time we were here, I was actually merging the smaller pieces, and we did that, I believe, in this node group or in this subnetwork, where we've taken things into the pack and we transferred our name attribute to give us the ability to have the closest points from the points that are bigger, from the bigger chunks into the smaller chunks. And because if you see here, if I hover and middle click, we'll have 30 points here, but our name has also 30 pieces, and here our name has generally less pieces, and the more scattered there is, the more significance we will see here. So if I put this up to a 500 now and I wait for it to bake and cook, and if I look into it here and I hover over it, this will be 88 and this thing will be up to 124. So what we did is we basically have packed them in a different way, where we took the data, the name attributes from the bigger chunks and transferred them to the smaller chunks, and now we ended up with 41 instead of having 124 attributes or strings here. So yeah, we have did that, we have done that, and then we unpacked them, and then we applied the merge, and this had allowed us to merge those small pieces together. And the comparison is right there. If we watch this, let's go into the exploded view and take that thing a bit lower, right? And then we could put it in the old, the normal, before the processed input, and we will see smaller pieces here and there, like this here, I assume. If I hook this one up here, you will see it got merged. And that's due to the work that we've done. Okay, so far so good. We will go back, of course, and learn some more tricks and tips, and I will basically try to explain what I've learned and share my learning experience with y'all. Progress over perfection. We'll be right back. I want to basically test my understanding, so I want to take this delete small parts here and do it the same way they've done it now in the course, where they play with the parameter after they have the exploded view. So we'll just put those things back so I have more space for this, right? So here we go. So now we have a bit more space for it, and we will disable this thing or play with the bar here. Let's see how that works. Is there any change? Is there any change here? Why is it not? I mean, sorry, excuse me for my mistake. We have to put the merge in here. All right, now I can play with this value, I believe. It's such a low margin, like you see it here, how it's merging things in there. And I think that's due to how we have our planes. So if it was on 0.5, you see that it's merging the different parts here. And if I hook it up to the null, you'll see a whole different result. So it's basically acting a little bit like the cluster, which is pretty cool, but we don't want it to. We just want it to merge the small pieces. So this is definitely a huge value. Maybe we can go with 0.2, check those values. I think this is also still too big. But yeah, it should work. Okay, I muted. That is fun. Good thing I didn't take it too long, because I completely forgot that I muted. It's fine though. Yeah, now we fixed it. It's not in the recording. That's pretty well. Let's go with something like food, fitness, dance, gaming, chat, interview, beauty and fashion. Where else there is? How the hell? So if I put this, okay. It's funny. It's funny. Okay, let's go with education then. Okay. Good. And let's go live. Good stuff. All right. Now, we're not muted anymore. And hopefully we could get this thing to work. Give me a second. I just noticed that my mic was not hooked. And it's just gonna check the sound. Good stuff. And we will go here. Device is not connected, not available. What do you mean? That's weird. It's quite weird. Sound check. It's working. Okay, good stuff. Then we will start playing. Good. So let's play with that a little bit, people. Just notice that I'm still recording. Is this? No, it is still working. Good. Then let's check it out together. And so what we will do is add something called RBD. What is it called again? Let's just look at it again. It's called RBD. RBD. Oh, give me a second. RBD interior detail. That is what it's called. Okay, so let's check RBD interior detail out. It is. So we have the system, right? Let's go back one backwards here. And let's go and add our RBD interior detail, right? So right after the delete small pieces, if we go and put that thing here, we have an exploded detail, exploded view, sorry. And we hook that thing to the exploded view inside of here. And then we basically take our interior. Wait a second. Let's view our exploded detail, check inside of here. And now you see that it immediately took the inside attribute, not the outside one, because that will basically change the outside look of it. So let's take the inside one and see how we could add more deformation. But first we need detail size. We need to make the mesh a bit more detailed, I think. That's a bit too much with, yeah, that's fine. Yeah, you can see that it had definitely added some more, yeah, look at that. Like, it had added so many subdivisions. This could be very performance heavy, but if we like optimize it into like 0.03, and then we just add more cusp angles, I think, or the noise, this one, the noise amplitude should give it more details. And this one should make it, wait, let's see how crazy we could get with this. Let's view it a bit from far. And let's take our view into the flat shaded here. Does this show it better? Not sure, honestly. Let's see. The amplitude, let's play with that. You see that it had definitely added details from before. They are looking very chunky, those pieces. They have very rocky feeling, or very breaking apart feeling. So if I put 0.015 here, we'll see even more details now as we go. Here we go. Yeah, this is pretty cool. And we could also apply it on the older system, just to, like, it could be a very easy way to add details like that. But I think we could do that with our texture pretty well and in a better way than this, because I think this is pretty performance heavy for now, but it's good to know the type of effect, so to speak. Let's bypass the rest. Let's see what we could do. With the goal, and I haven't paid attention fully, is to basically have this being enabled and disabled in the properties. And so basically we will have our new workflow, right, this one, and our old workflow basically split in a switch, or with a switch, And so let's see where it starts and where we could make this thing happen. This is connected to this active group, and I feel like this thing needs, I kind of need those to be upwards here, just packed a bit more. What is the result of that Veranoid fracture? Let's check it out. Does it still work is the question. Scatter. Yeah, it is still working. And we basically want to switch things before here. One right after the Veranoid. And we will have that workflow with the exploded view. Pretty normal one we've had. Actually, that's the more complicated one that we made. We have Boolean fracture. We have match size. Yeah, we worked on that. If you want to explore that later, we could do that. So let's just group this thing. We'll call it slices, manual slices. They're not so procedurally made, right? We have a fuse that takes the inside parts only. And then those inside parts are being fused, cleaned, divided. Remesh, how's it going, Ozio? Ozios, I hope that's how you say your name. Nice to have you here. Remesh main mountain, which adds the noise. The bound, which should make the sizing, would scale the sizing of those slices. So it is kind of procedural, honestly. It takes whatever comes out of that. So let's add this into one subnetwork. Let's add that subnetwork. So let's make it first. All right, so right click on the nodes, actions, and flags, actions. Let's see which one we go with first. Parameters and channels. Actions, and collapse into a subnet right there. And so we will call this subnetwork, we'll call it slices operation. So now our naming convention was like OP for operations, so the 3 letters of the actual grouping. And we will call this slices workflow. I call it slices because it's a bit different than what we have here with this type of workflow. All right, now let's bring those UVs honestly back into the game. I feel they need to be right back here. And so let's just check what is happening here. Where are we packing? Why did we pack? So we can group. And then we unpacked and put it in the random. Okay, so that is the workflow where it keeps going into that direction. Operations are yellow, so we will just add the yellow. Fine. This will end here, and this will start. We'll probably keep this as our main operations for now, but we want a switch in between those two. So basically we'll have a switch here, and that switch will be right after the Veranoid fracture. And we'll just add it. And so obviously it needs 2 inputs, right? To switch between them. Let's see. What do we need? It's probably going to happen right after, all the way here. I bypassed that because it was just an experiment. So let's enable this. And now I'm going freestyle, by the way. The whole time. So yeah, we will just check that out. We have that switch that takes the input, the normal one, right? Non-complicated one, and the one that is a bit complicated. Puts it right there. And basically I would like it to give us testing between 3 results. So instead of a toggle, I will have a menu in the parameter that switches those things. So, and what I will do is take all of this and now downwards. So let's go down. It's going down for real. Here we go. So instead of hooking this up in here, I will probably, no, wait a second. Yeah, let's hook it up in the other one just to try it in the switch. And see, this might break some things for now. Good, didn't break anything. It's taking anyway the main input as 1. Okay, so and let's check our inputs. 0, 1, 2. Okay, it breaks immediately. Okay, that's good. Not in a good way, also not in a bad way. It definitely had not only broken it, but it had has to do a lot of calculations. So let's check about that. Okay, the 0 had worked. Let me try to check. Do we need the packing here to happen before as well? I mean, this is basically nothing else, but do we need this whole process to happen maybe before that switch? Let's try that. I mean, we're just trying things, right? So let's do it. We'll just put this whole process here. And we will hook it up. Let's see what happens. And then basically things will go... instead of them going from the fracture into the thing, let's try to put the UV... Let's try to put the UV inside of those inputs, inside of the fracture. So let's see how that works. Let's see how that will work out for us. Just curious. So yeah, now I think I'm messing things up too much right now. Too much experiment right now. So let's not do so many experiments. Let's go Control Z. Let's go backwards more. It's gonna take some time, so we will go. Yeah, with the normal workflow that we had, I will check with the workshop and let y'all know if this had worked. I probably know what happened here, so we'll break. First of all, we'll just put our switch back to 0 before we break the stream, and we'll wait for it. Here it is. Good. This exploded view now we'll just remove, and we'll also remove the RBD interior detail. It's cool that such a node exists, honestly, but we will delete it, and that was one of the mistakes we've done, I think, working with that. And so yeah, okay, so one of the things I want to do to make the calculations a bit less expensive, so we'll go with 200, maybe 150 max. All right, that's doing different things. All right, so 150, let's see how that will look like. And we will not view the last output. I will actually go into the UV generation, or maybe into, where did we go right after, in the exploded view here? All right, let's check this exploded view. And now we will switch. All right, so let's check what's inside of here. We have an exploded view. We will bypass that. Boolean fracture. We will keep that. And so backwards. And let's take our second input in the switch. Let me click on it and go to 1. See where the errors are. What is it saying? Invalid source. Infinite recursion in evaluation. Might be due to some loops in there. Now I wonder what happens right after the fracture on his end, so I'll check that out. Basically, my setup has the same. I think basically not just I think, but I know that the switch should come right after the, you can see here's the mistake. Let's delete this. Let's try now to delete this input here. I don't want it yet. So let's just delete that and go back to 0. 0 works. 0 looks good. We will definitely go to our exploded view here, let it cook. Then we will slowly go into... Alright, and now in the switch, we'll check the 0, 1 input. That input had created problems now down the line, right? Is that a baking issue, or what's the exact deal of the problem? Are we still getting the loop thing problem with infinite possibilities? Invalid source. We have the draws here, HDA to gen cutting plates, generation cutting plates, split 2. Okay, so in the split 2, inside of generation cutting plates, we're getting an error. In the split 2. Okay, so what is the invalid source? The inside is invalid? That's interesting. Let's go backwards. Maybe the connection to the Vernoid fracture had broke, so we will add that here. And wait for it, wait for it. So this had solved the problem here, solved the problem here, and solved the problem here. And if I look into the exploded view, which is right there, it should have calculated it now for us. So where is it though? Where is it? We're getting some type of... All right, so merge is here. Exploded view is not visible, but the merge is visible. Maybe the exploded view is too high. Can this be? Let's go back in here. Open this thing here and go with explosion value of 0. Yeah, just 0.1. And let's check our exploded view. All right, so yeah, we have solved that. That looks good. I'm just trying to figure out ways to solve this problem we're having. So yeah, we're learning as we're going, definitely. So yeah, that's the actual updated now, our updated, so what is it called, collision. That's pretty cool, guys. That's pretty nice. What we also want to do is, let's just close this off. Let's dive into one of the major things is that I want this to work as well with it now. So let's check. Yeah, everything is fine, hopefully. Let's hook it up. It should be its third input now, which is number 2, because including the 0. All right, and now we wait. It will bake. It baked. Ooh, look at that. So 3 of them work. I would love to introduce the small pieces cut thing we made here. So we'll basically just copy this and introduce it to the same workflow. So we'll just delete the connections. We don't need that. Let's just put this here. Connect our thing into the switch. And now take the thing right in... Wait, let's make this upwards. Let's put it upwards. Put this thing here. And now delete that connection because it has to go through the operation delete small pieces first. And this had definitely now deleted some of the pieces, which should make it more performance friendly. So this is the before, right? It looked like this. A lot of small pieces are involved here. And the merge looks like that. Still having the same major shape of those random breakings that we created using the mountain, which is a noise. Actually, how did we do that? We went into... No, wait a second. This is the cutting. Yeah, I think we made a mountain, right? Mountain, yeah. We first started with splitting the inside geo, then we've added fuse and clean to it, then a divide and remesh, and then a mountain. That's how we've done it. It's a cool workflow. I really enjoy that. Then we have the collision of that, which should work as the final result. So far, pretty clean, I would say. I'll give this a different shade of yellow, just because it is a different type of operation. It's like it's an operation that we can copy over and over, and just keeping organized with everything. So operation slices workflow, generation cutting plates. So this actually generates the cutting plates. Let me just review our workflow here. We have split the same workflow with the inside, the same clean divide remesh mountain. Yeah, we have split them away from each other. Then we added the Boolean fracture operation right after that, which looks something like this. It first starts with the bounds and the resize. This is to keep the size of the things of the matter. And this one should basically, so this is fully functional because it also communicates with the shape. This is why this one is better than this one here. So this is not yet fully figured out, so to speak. So we'll just add a shift O to it and say basically a warning, not fully figured, not fully configured. We will say missing, yeah, whatever, missing dynamic mesh question mark, because I'm not sure yet. So let's make this a bit bigger. And dynamic mesh isn't thing in Houdini. I'm just trying to name it in a way that makes sense to me, because I think it's not pulling the box from anywhere here. And that is why this operation Boolean fracture is so important, because it's actually pulling the data from the box. So if the box changes to a sphere, we might actually try that right now. So we'll save it and go back up here, and instead of the box, we'll add the sphere, and this should update in the operation Boolean, I think. Operation delete small pieces. Now wait, not this type of shape. Excuse me. No, we'll just Control Z that. I ruined it. Wait. We will just connect the proper one now. We will wait. No problem. We have all day. Okay, so the sphere should be... Oh my god. Excuse me. Okay, so the sphere will be here instead of the box of the original shape. And now we'll see what will follow. Which one of them will follow the suit of... Yeah, good. Let's see which workflow followed this now. We'll go in. We'll see that operation delete small pieces, which is the operation of... It's the same operation, more or less, just it has this operation Boolean fracture instead of just continuing with the current shape. And it goes right into the switch, right? But how does this look like? We see if we add an exploded view, it shouldn't follow the suit, right? Because it's just working with bounds. Oh, that looks good. So it is fully configured in a way. And I'm trying to figure out what's the difference between this and this. I think this is faster. All right, so something is missing. Something is missing. Test performance. Yeah, something is missing here. Good. Now we will add that thing as we said, and we'll create the parameters. So let's do that. Right click on the DGA, type properties, and we will go with not only the parameters, but also, let me check. All right, now it will be a parameter. It will be a menu parameter. So let's go into that. Minimum max. Is there a menu? Angle button strip, blah blah blah, data direction vector 555 float folder geometry icon integer key label logic logarithmic I don't know how to spell that operator order menu RGBA spectator spacer string toggle UV and UV. All right, so here render properties, node properties from nodes. Trying to think, where was that? How did it look like? I mean, one way to check it out, go back to our bridge here. Just let it load, let it cook. It's fine. It's not a big deal. Now right click on that. We'll just have our bridge back. It doesn't matter. Right click on that, type properties. And where's that? We have a folder, rope style, this thing. What is this parameter? It is an ordered menu. And its original value was... All right, it's in the O, basically, not in the M. So yeah, let's go back there. Our bridge will be gone in week 3. If you're curious about the bridge, what the hell was that bridge? It happened in week 1 and week 2. Now we're currently in week 3. So check that out on the YouTube channel in the playlists. Okay, so DGA Drosphere. All right, so that is our second. That's our iteration of it. So we'll double click on it and we will, all right, now we'll go to type properties, trying to focus. So type properties, go to the ordered menu. So ordered menu right there. Put that thing in here, call that ordered menu. Now what happened there? Wait, ordered menu, good. Let's take type of fractions. All right, and it should have 3 options. Let's see together how to do that. Channels, menu, and we should be able to create new stuff here, if I'm not mistaken. All right, so we'll go first one. The token is 0. It will be called no details, or simple. Simple, right? The second one will be 1 basic, not basic, medium slash performance, and now we will know if we could add the slash here. Good. 2 will be big, not medium, but detailed slash heavy. That's my current guess. This is only for us. This is not yet to be named properly. So we'll apply that. We'll accept it. And now we will hook those things up inside of the switch, because the switch has 3 inputs. So we will hook each value to it. My shirt button just popped. Doesn't matter. Let's go inside of here. And we will go into the switch. Let's pull the menu from there. Take our, let's see how to do this. If I go here, select input, let's take our, why is it called label? All right, we're gonna change that, honestly. Right here, right click on this thing. No. All right, so right click, type properties again. Go to the label. It shouldn't be called label. It should be called type of fraction or detail. Not type of fraction as well. Detail, fraction details, fraction detail type, detail type. This is just something we are refining for ourselves. It's nothing in the documentation or anything. It's just for our own understanding. So we'll accept that. All right, accepting, good stuff. All right, we're gonna just wait for it to accept. And here we are. We had accepted it, definitely. This looks great. Nothing changed, basically, what I'm just saying. It looked great. And if I take this now, put it into select input and get the absolute channel reference, I will be able to change to medium performance now. And this should be able to change the reference. It's the line that is thick, and it's not pointy line. Simple, it's switching for us. So it is working. Detailed heavy, that is our, let's see, that is not our detailed heavy. So that's first of all wrong. What we'll do to make it fix this, we'll just switch the values inside of, actually we can change it right inside of the switch itself. So we'll just switch those 2 values here. And now the detailed heavy will be our red one that we're not sure about yet, but might be heavy for Unreal and might even crash it. Let me know if you're here and let's interact and learn. That is actually something I wrote. Okay, I will pause and we'll be right back. I need to go to the bathroom. Part earlier with the stream later on. So let's go add some more controls to our HDA, and this should be fun. So let's make less space in the view because we need more space here. And one of the very first things that we want to promote, or promote into parameter, we have to do it pretty much a lot of times. And I'm wondering how we should be able to do this. Yeah, that could be a good practice anyway. So let's go into it. Type properties right there. And let's start with our cutting plates. All right, so those are generating our cutting plates. And we want to first go to the remesh. Actually, this should be on the left. Let's make this smaller. That's fine this way. Okay. Maybe this thing also bigger. Can I? No, I can't change much. Yeah, well, that's unfortunate. It doesn't matter. Then we will go here. Instead of the left one. I mean, can I just put this down here? Why is it so big? Yeah, we can make it. Hey, let's put this thing a bit smaller then. Okay, and now, yeah, I'm funny struggle with this screen space here. Okay, so the remesh will need. Oh my god, this is a bit annoying. Wait, let's make the view a bit bigger again. This is here, and this smaller again. That's fine for now. Okay, so we need our target size to promote it. So Alt middle click. It should be basically here. Then we want our mountain details here. So first of all, our amplitude is very important, and our element size. Okay. Now we will see if we change the element size, what would happen though. All right, we're not viewing it. Okay, so mountain. Let's see what happens if we take our mountain size and play with it. Yeah, okay. Yeah, that makes sense. It looks very watery though. It's pretty cool. Yeah, so this will be like a noise texture size in my opinion, because yeah, it affects that noise texture size. Yeah, and we'll put it right here as well. Then we have our amplitude, which should resemble, yeah, how much the effect is happening in the upwards and in the downwards. Yeah, it is called amplitude, I would say. Target size, that would be our remesh operation. Remesher, let's just call it remesher. It's fine for now. And the minimum value should not exceed like 0.07, so we don't get crashes. Or 0.8, honestly. We maybe 0.6. Okay, so we don't want any crashes. We need that range, right? Why am I in scatter? Okay, noise. All right, remeasure. All right, so those three now we need to make them control many others. I will put them in a folder, honestly. So let's put a folder. Where is our folder? How to add a folder? It will be right there. So folder, add. That folder name will be called detail controls. So fraction detail controls. Controls. Here we go. And this will be down there with the rest of them. Also the menu that will be inside of here. That's fine. Okay, and we'll apply it, wait a little bit, and yeah, basically accept it. No, wait, before the exception. I mean, yeah, let's accept it. But what I wanted to do is hook the same values here in the fraction detail into each and every remeasure from the others as well. So we'll go backwards. I think we've done this here now, but we need it as well here, like anything else. So let's do that now. We have fuse, we have clean, we have divide, we have remesh. So remesh, we need the remesher value. And we just put it in here. Why is the remesher so low? Although we have limited it. Not actually, it's not so low. It's fine. Okay. We'll put it here and give it an absolute channel reference. We don't want to control it from here again. And let's see if it had saved it. It will wait, of course. All right, and now we have a channel reference. Then we have our amplitude that is in the mountain. And that amplitude needs... thank you for the follow. Appreciate it. Who followed? By Baymax 1993. Nice to have you here, my friend, and thank you for the follow. Appreciate it. Okay, so let's keep going. In the amplitude here, let's have you in the chat. We'd love to know you. In the amplitude, we have 0.22. Let's take that and put it right here, if I'm not mistaken. Yeah, should be fine. Relative channel reference. All right, good. That is nice so far. And then we have the noise texture size. That will be our element size right there. Noise texture size in the element size and relative channel reference. And I think so. Relative channel reference. Absolute channel? No, in the absolute. Then must have not been paying attention then. We'll break that connection here. What was it? Yeah, okay, so amplitude. Okay, Control Z that, Control Z this. We don't want any Bezier or whatever. Control Z. I don't know what I've been doing. Okay, so and the amplitude again. Let's get absolute channel reference. Actually, I enabled the bot. I'm not sure if people can comment anymore. Let's continue where we left off here. We have definitely added the remesher. We've added the amplitude, and the noise texture size. All fine so far. Just in order. Okay, let's just break that connection. So right click and delete channels. I think. No, wait. There should be a value here. Include and take. Delete channels, I bet, is the one. So let's just wait for that. Because it's a remesher, it will take some time. I'll give it the absolute channel reference. This should help. Okay, and it will basically bake and cook a little bit. Okay, so that is fine. Yeah, the rest is doing well, I believe. So week 3, our geometry in week 3, and our HDA, and then let's check our operations in general. That is good. We've done our work here, and we've done our work here, and all what we have to do. I mean, no, really, not really. We should just disable it when we go into simple. We should disable those. Okay, so let's do that. So right click, type properties, and let's disable all of those and hide them. Disable when, and I forgot the exact expression, but I'm trying to think. I mean, I'm sure it will come in the tutorial now, so let's pause and go back there. We basically went through our day 9 and we found the ability to do it. It's basically nothing else than columns, and you add the exact name of the label, and then the equals, and then you say either the 1 or the 2 or the 0. Okay, let's do that in our Houdini. Let's go into here. Just learning takes a lot of patience, and good thing we're documenting all of those stuff, because honestly I could easily recall my own experience, but it's harder to recall the experience from like the actual recording, where that was, in which video. I can't recall that honestly, but I can recall when I was doing it. That is the benefit of learning by doing versus just learning by watching, I suppose. Okay. Okay, so let's go to do this. So this will not change, but our remesh will change here. So disable when. Let's get those brackets. I don't know what they're called yet because my English is so bad. Let's call it. All right. So what is the name of the label? Fraction. Detail type. Good. Detail type. Big T. Here we go. Equals. And now we should know the values one by one. So 0 is our simple, so only hide it when it's simple. So let's do it here and remesher. Where is it? Noise texture, amplitude, all of them basically. Yeah, we'll do it on all of them. And 0, this should work now, hopefully. Do I need a semicolon at the end? Do I need that, Jack? Jack says, let's see what Jack says. It's cool that I could actually show my own tutorial without even. That's pretty cool. Not tutorial, it's a video. It's not a tutorial, it's a documentary. Okay, apply. Good. Let's go here. Amplitude, disable one, apply. Noise. All right, one last thing. Noise, disable one, apply, and now accept. Hopefully we don't have any typos, but there's only one way to find out, and that is to test it. So here, here, here. Nah, it's not working. We probably need 2 or more different. Maybe we've added a typo, honestly. So let's check that out. So let's take our fraction detail, the label name, and now add it inside of here. Yeah, they're fractions. It's not fraction. Fractions. Okay, let's do that. Let's apply this. Always the spelling. Always question your spelling, because those are the most frustrating things to fix. If you're thinking logically, but then you've misspelled one more thing. All right, so remeasure is obviously not hiding. In the medium, when we go to the medium, we should have the options open for us. Remeasure is not working, so let's check why that is the case. We'll go back to the object, go to our type properties right there. And let's go to the remeasure. Let's see what the remeasure is saying. It's saying still fractions. So, go back to fractions, apply that. It's like I have the feeling that if you are like dealing with a lot of code, you kind of need to be a bit of a reptile, like thick skin, and and just like brutal, no feelings, just like just deal with the actual facts and nothing else. Good. I'm turning into that slowly. Well, that's good. All right, good so far. Let's check the tutorial. Maybe we have to import it now into Unreal, so let's do that actually. So what we'll do is save, make an incremental save with w.2 for week 3.2. GGA draw sphere. All right, so first let's go Unreal and tell Unreal, yo, you know what we need, my friend? We need to connect our Houdini session. So we'll create a session and we will wait until Unreal is connected to Houdini, and this will take some time, but we shall be there. Slowly it's happening. Let's go to all and content and go to our HDA. Actually, we could just choose it from here and we have a session. That is amazing. So what we will do is go back here, right click on this thing and save no type. This will allow us now to save this thing. I should have before actually doing that. We should have. All right, so we're gonna wait for it. All right, here we go. Just so Unreal doesn't crash when we import that thing from 0, if we ever do that again, we kind of need default values on those things. So here, the default value need to be 0, which is in this case simple. I like that. The remeasure needs a simple value, the default value. Okay, so that is a good default value now. Let's keep that default value. What is our minimum? 0.08. Okay, that is good. Our noise texture, does that have any default value? We'll check that. We have a default value pretty well. I like the idea of like importing those things from their node by like alt and middle mouse button them, because they get you the default value of the actual current value. All right, so let's right click and save node type again, and let's right click rebuild all instances. We'll let it cook. We have the cooking process now, it's cooking and we'll be right there in a couple of seconds. So pause this, let's record, and let's start with our this is a bit too less of fraction, and the reason for that is that our cube is too far away. So we'll just add it right there, hide it again, we'll let it cook again, fine by me. So we'll pause that, and now everything, it had finished cooking, which is proper good. We have our collision, it's in the middle. All right, and now we will play with the parameters without enabling simulation. That is pretty well. Let's check. I don't like how this is looking like already, so we might have to change that later. So fraction detail controls. Basically, let's go to our explosion value. Put that thing on 1. Now we'll see a type of explosion that will be probably recooked. Yeah, every change we'll wait for. Here it is. Here's our explosion. Pretty cool. I think we have a huge cluster value on the things. This is going up because the actual, you know, the what is it called, the help me god, the collision is keeping them together, and we want to be able to disable that collision and enable it whenever we want to, so that we could apply like that type of collision to an explosive, for example, and then it will explode. But for now I'm just checking our collision here. Okay, not our collision, but our explosion. What I would like to add is different type of fractions. So yeah, let's do that. That is exactly what we were testing before. So let's go into the Houdini HDA. Let's go and tap on our fraction detail control. And from simple, let's go to medium performant. Type of detail. We'll pause this result, people. Look at those random. Oh my god, look at how beautiful this is. This is amazing. Wow. Look at that. We did it. This fraction is looking pretty well, right? Amazing. So let's put it to the test. Let's play it together. All right, play. Let's check it out. Boom. Look at this thing. Those are not simulating due to the actual collision that is keeping them together. So yeah, this is looking great. I like how each individual piece is different, and it is not anymore so weird. Okay, let's stop the simulation. Let's put the explosion value back to 0. Let's also mess with some, let's bring this value a bit upwards, like a 7, so we don't end up cooking for so long. Explosion value to 0, and it will load now. Let's add the fraction value as well to like 500, see if it breaks, see if it just breaks everything, and we'll just wait for it honestly now. So it will do a huge remesh calculation. I'll go to the bathroom in the meanwhile. We'll be right back with ya. So be right back, people, and see you in a bit. Be right back. Be right back. So, oops. We should have better cuts of this, and it's not exploded, so it will happen once we simulate. And simulation happening, boom. We can see that it got reduced a bit to lower results like we had them before. It still looks better, but it's due to the remesh being higher again. And so what we will do is change the amplitude and see what that would do. Okay, so let's pause that. Pretty much optimistic about this thing, so let's play it. Whoa! Okay, it had definitely broke off. I don't know why the rendering is making them disappear. There must be something in Unreal, maybe a setting here or there that is causing this thing to happen. But yeah, for now, if I zoom out, actually, we should see it happening. Like those are the pieces. But it's interesting that when, yeah, the shadow is not doing well, I bet it's due to the like conflicted geometry. Yeah, this is not proper. Yeah, because there's a lot of conflicted geometry and flipped normals at the same time that it won't render properly. Okay. So yeah, now we know if the amplitude is higher, we will have some problems. Okay, so let's stop that and pause. We have learned that the amplitude to 0.25 is too much. If I do it inside of here, with the help of proper duck games, of course, we have figured that out. 0.25 is too much. Let's go with 0.213 and see how that would work. Also, in addition, if I make the noise texture here lower, see, we get more details. So let's Ctrl-Z that and also lower it after the bake, of course, and check what we could do with that. I hope I'm not dropping too much frames. Put this thing to the test. I wanted to eventually put the noise texture size to something lower, but let's see how that works. Boosh. And does it still render? Is it partially rendering or... Yeah, better than before though, but we still definitely have issues rendering it. What happens if I put this thing on full screen though? Yeah, we're having those weird shadows plus weird everything else. Yeah, we don't want that. I'm trying to think how we could fix this. However, the actual difference in the cuts is pretty neat so far. Let's see if he is having the same thing in the tutorial or not. Yeah, this is pretty neat. I like it. But whenever the camera is changing, they're disappearing. Pretty weird effect, I would say. So yeah, let's see what is causing that. Okay, so we'll pause. Fracture mode. So we will test this render issue now in the fracture mode. So let's select the actual geometry that will be exploded and go inside our fracture mode and might crash. So are you gonna crash? Yeah, it's just crashed on us. I think that is the issue. The render issue here is causing this stuff to happen. Could be wrong, but we'll try it again without the recording. I finally made it go back to working. Finally. Now we can actually view our settings quite faster if we go into the fraction. And my fraction mode or my fracture mode here is not working once I put the scatter up to 500 or something. So above 200 it's crashing on me. But what I find out immediately is that I can actually render this. That is renderable. And let's simulate and see if that will be renderable as well. The shadows are leaving a trace of some type of weird shadows we're getting here. And I wonder what is causing all of this. But at least we can see them as we go. So let's check what is causing this issue. You know what? Enough problem solving. I don't want to be problem solving the whole week today or this week. What I will do is I'll go into the course and try to advance in the videos because we're currently still in halfway there. I kind of want to go forward with it. All right, so pause. We'll go freestyle now. I've watched a little bit of the tutorial, definitely, but I want to go freestyling. So freestyling it is. Let's do some freestyling. Yeah, definitely invite people over. Absolutely good and great idea. Please let them invite their people, and then their people need to invite their people. I just want this to explode. You know what I mean? Let's make a cult here. The Generalist cult. Nah, just kidding, of course. Well, we have an output, and that output we need to... Okay, so let's see. I'm trying to focus here. We have a split... All right, so let's go back, and now we'll create a different way to create our fracture. Instead of having a box here that basically... All right, let me show you what I mean. Let's see, we're gonna look at it. All right, so right now we have that box determining what type of objects will fracture and what types of objects will not fracture, and it is currently interfering with the sphere in that way. This doesn't matter. It could be a sphere, it could be a box, it could be anything. So what we will do now is take our original box and basically make it look like a wall. So we will do that. I'll take this box, view it, and press enter in the view, and now make it look like a wall. So we'll make it thinner. We will go into the side view. Yeah, probably this view. Make this smaller here and bigger here and smaller here as well. Smaller here as well. And go to the normal view, the perspective view. This is looking pretty well. Yeah, okay. And we'll make this bigger. All right, this looks cool. What else do we need? This is pretty good for now. We need a curve node into this thing. So to be able to determine this thing through a curve node. So instead of a box, I will delete that connection. We have a nice wall here. Just for reference, we need to add our Tommy. I think his name is Tommy. Tommy, where are you, Tommy? Here it is. Tommy is here. Yeah, that's too small of a wall. Was to be expected. So let's keep Tommy as a reference. Create the wall around Tommy. Let's create a wall. That is like a fence, honestly. A wall is a bit... Yeah, like that's the typical white man, right? The typical white man average is 175, 180, I think, tall. Yeah, something like this. This should be fine. Okay, good. Tommy's gone. I don't like Tommy. Bye, Tommy. And so we will basically now add the curve input instead of our box here to determine our fraction region. Okay, so let's do that. Let's add a curve draw. Curve draw, I think. Curve draw. We have a new message. We'll check it a bit later. And that curve draw should be taken from the box, I remember. And we'll be hook it right over there. How do I change? Wait, let's take the box from here, maybe. I need to check how that's done. We'll be right back. We got a hot tip. I always like to highlight the hot tips because I enjoy them, because they cut a lot of time and it's interactivity and it's pretty cool. So in the projection, Lotus says, and in the projection here we could, but what I would like it to do is only change on the wall, basically. Not only the projection itself, because he was able to do that. So I will also check the tutorial if that actually happened in the tutorial as well, because I think he was able to connect it in a smart way where this is where he's able to do that. So let me check that. But thanks for the hot tip. Look at you, Lotus, giving us all the hot tips. So yeah, we have to go to geometry. And this should, if it's hooked up properly, we should be able to draw on this way. Let's view it first. And let's see, are we drawing? Press W. Yeah, exactly. Nothing here. Okay, so let's check the other input and delete that one. Yeah, look at that. Thank you, Lotus. Thanks for the hot tip. Now we'll draw a star. Oh, that's a star. Cool. So yeah, basically we want to do that. We want to do the fraction and decide what does the fraction, what doesn't, through a curve like that one. Yeah. So yeah, let's see what we could do to achieve this further. Well, one of the things that comes to mind right now, and that a lot of things won't work, of course, anymore, but that is not a problem. We'll wait for it to respond. Oh, actually, that's quite cool. W back. Look at that thing. It looks awesome. Yeah, we'll work on that. Let's see. Go back here. Okay. And now we will basically start creating some solutions. So first of all, let's create a subnetwork. Oops. Let's create a subnetwork. And that subnetwork will be called smart. How to say? Generate region is the way we're trying to convey this. So we'll call it smart. All right, so it's a gen. It will generate a smart region because it should be also able to determine is that an actual geometry hook to it or a curve. And we will do this with a switch if. So let's go inside. We will first of all add a switch if. So first let's add a null here so we don't have to pull from this thing all over the place. And let's add a switch if. Here we go. Switch if, and now we'll try to understand that thing a little bit better. We will attempt to do so live. And so we will make it go in both inputs for now. Later we will do it a bit differently, right? So Shift S just to have it clean like that. We will basically put this into the first input and we will run it over the element count, so we will be able to basically see if it has a polygon or not, because a curve is not a primitive. It won't change to a primitive. It's just a group of points, I think. Could be wrong. So let's go with number of primitives. If so, that right now it's saying if the first input has a number of primitives that is equal to, I think, higher, greater than 0, then it should go to the second input. All right, and now we will see how that is done further along the road. But that is what the switch if does, and I think I understand it a little bit better. It's a bit like code, but it, you know, they structured it in a nice way to make it work. So yeah, we'll keep going. Check this out. Check this trick out. So now we have, let's call this null if it was a primitive. All right. I would like to call it if to just fit the actual scenario here with the, oh my god, tab null. Another null, and this one I would like to call if it was a curve. Right now it is a curve, so we know that. It's fine. It's about changing it from the hierarchy upwards. So let's put this thing here. And we will run it now through some operations like Robin suggested on the chat. So let's do that. Okay. We have here, we could add a resample to it. We'll just leave things to their basic. Where is our curve though? Why is our curve not visible? All right, let's check it backwards here. It will load. Let's make it load. Draw curve. Here it is. That is visible. I think we didn't draw anything yet, so let's draw. Yeah. All right, let's do this. And let's go inside. I hope it saves. Let's see. Yeah, we have a curve. That's amazing. We have our resample. If we check our points, it's doing equal point generation on all of them. And what we will add now is a... So we have a resample. We'll add a smooth. So let's smoothen up. Right there. Let's keep the settings as basics for now. Then we will add a sweep operation. Because what we want eventually is to make this thing be the region. And what do I mean by that? Let me show you. Let's change this to a round tube. Make it, let's not add too much geometry. Let's make it bigger in the radius. And keep, I mean, it's good for now. Okay, so and we change this to grid, which will add those two caps at the end. So none looks like this. It's open, and if we have grid, it will close it off for us. And then we'll just expand that radius and try to make it even bigger. What makes this bigger other than the radius? That's fine for now. Okay, yeah. So we want this to hook here now. But the thing is, this had become a primitive now. I wonder how we could change that. So yeah, give me a second. We'll be right back. Set up a system that would do an automatic boolean between the current sweep operation. So what I will do, I'll just disconnect this here. So we'll add a boolean as well, because we will basically be working with that. And we will pull the data from the original box we are working with, which is right here. That box, that shape right now. It could be a box, it could be a column, it could be a rocket, it could be anything. So what we'll do is add object merge, and we will basically, all right, so we'll add a null as well. Fine by me. Let's connect, wait, let's connect everything to it. So just pick them up like there and just put them here. This null will be called mesh. Fine, good. Let's take that mesh data, put it right into our object merge, right? Now we'll control X that thing inside of our subnetwork, and right inside of here, V, we have an error, and that error due to the hierarchy. So 0 dot slash, and this should make it work now. So if we add this and boolean it with this thing, and we add a null here just to see the actual result, what type of boolean we're getting, we need a boolean that intersects, so that only the intersection will be the region, so to speak, where the fraction will happen. And so you basically will be able to draw that line with a curve. Maybe you would be able to even do it in real time. I could be completely wrong about it, of course, but let's see. I'm just trying to imagine different ways to make this work in real time. I think the resampler is doing too much resampling, so we'll go with a bigger number, maybe a 0.3 even. That should determine. I think we will add some type of noise into this. But yeah, that is the major concept for now. Might change as we keep going and as we keep learning. So let's pause. So we had a problem with the mic. Not a big deal though. So we'll just check it. So yeah, let's start from what we were doing. I'm not sure how long this has been happening, but I could check the YouTube because go back into learning. And thank you, Burnt Beans 420. Cool name. Yeah, okay, so we were trying to make this work. My mic was weird, and so let's try to review what we've done so far. We have added a new null here, called it in region, and then another one for out region. This should show us only what's inside of it. Let's just check here, put that thing inside where it belongs, in the switch if, and this should show us now the actual fraction or the actual region that we want to work with, right? And this one shows us the in, so whatever comes in, now it's a draw curve, and we've created the switch if with a spare input, so we can have 3 things going on, right? Because otherwise we only have 2 inputs. So, and to access the spare input, we have chosen it from here. So now what we're doing is, let me turn this back to true. What we did is, this was, I think, on input wired, and we changed the input wired to element count, just like in the other example, and we said enable when, so if the spare input 0, which is this one, the in region, so it's haven't been processed yet, if the spare input is what is it, a number, if the number points of the spare input 0 are equal to 0, then make all conditions either true or all conditions either false. And I think true means the second input and false means the first input. So basically, and that will only happen when the points are on 0 and they're equals to 0. And we see why would we need that. I still could not fathom why we're doing it. Maybe someone could explain it to me, but yeah, for now, We have that, and we have Burnt Beans saying some cool stuff, just some nice emojis. All right, that's awesome. Thank you for dropping by, my friend. By the way, I really appreciate it. We made it actually. Let's go into our. Yeah, I don't get it completely, but we could try to test it now. So, where is it taking its input from? Wait, escape. Come on now. All right, so show me what's in the switch if. It's gonna take some time. Why is it taking so much time? All right, good. So now we have the test running on the spare input. So it's saying, yo, whatever comes from the test input, this one, if the numbers of points are equal to 0, then switch to the first input. So basically we're saying right now, if none is provided from the, nothing is provided from the fracture region, please switch to the normal mesh. So let's see what that means. If I cut this, what would it do? Just wondering. What are you doing? It's taking the actual wall. Okay. And so if I hook the box, it should take the box as a region. That's an interesting result here. Where is this from? How does it look like? It looks like this. But why are we getting that result? That's such a weird result we're getting in the switch here. What the hell is this? What is this? How did it come to that result? It's making a frame. What? What is happening here? If I put this lower, what would happen? Would it be lower? Yeah, it is lower. Ooh, I don't know what's happening in here. That is super weird though. Such a weird way. Yeah, there's a lot of geometry that's not being connected and all types of weird stuff happening. Let me check if that's the result on his end. Okay, so I noticed by going back and checking the tutorial again that we haven't yet connected that part. And more scammers. Thank you for dropping by, scammers. And why is the Streamlabs not actually working? I added a ban on all those words. Doesn't matter. Okay, how can I just take an input from here? Thank you so much. Let's hook it into the switch. And this should give us the result we want. However, if I go one hierarchy upwards and one backwards as well, so in here, and now just hit escape because I don't want it to calculate everything. And then I click on the draw curve instead of the box. How would this change in this input? Nothing. So I could be wrong. Okay, so let's keep going. Okay. That's what happens when you try to freestyle things. Okay, so I get it now. I get what happened here. Okay, so let me go inside of our subnetwork. Let's go inside of our subnetwork from here. Let's hook it up to the switch, and I have found out finally where my mistake was. So, if the number of primitive is equal to 1, here 1, then what to do? Then, so if our first input, this one, has 1 primitive, then all conditions are true. Then please switch it here. So if we have in our first input a primitive, that means a polygon, please switch to the next. So whenever there's a polygon coming through here, we're gonna switch. Is the polygon coming through here? Or is this a primitive? What type of, okay, wait, let me check. It has 59 points and primitives are 1. So if I put a box, how many primitives does a box have? Box has 6 primitives. So when I hook the box here, which one will it choose from? The box. Anything with more polygon with more than one primitive, sorry, then it would hook it here. Now we see the curve doesn't have more than one primitive because it's a curve. That's the data type of it. So we're basically manipulating the logic through the attributes. We're saying, yo, primitive, what's up? Look, you're hooked here, but once you're more than one, so if you were a box, I want to take the box value. If you are a curve, I want to take you and process you through here. So it's like a guy who is splitting, who's asking, or if it's like a security guard, so to speak. I'm gonna just visualize this because I have a visualized memory. So I can actually remember that. Okay, so I'm opening it in here. And what is that notification? Oh, White Panther, what's up? Thank you so much for the thank you so much for the raid. I appreciate it. Okay. I will stop whatever I'm doing. Try to explain a little bit about what we're doing here. That's so awesome. Thank you so much. Okay. What are we doing here? What the hell are we doing here? And let's hope that Unreal won't crash. All right. Thank you so much. Okay, so let's play this here. What we're doing is simulations of fractions and distractions, and I'm documenting currently my learning process in the in attending a course at DoubleJump Academy to learn to become a technical artist, basically. We have made some cool fractions here that interact with the cubes around it, right? That's awesome. And we want to have more controls over it with the materials that we apply to the actual fraction inside, and the type of fraction as well, and the shape and the type of fraction. So if I may show you that in Houdini, I think we broke it quite a lot. I think we should be able to show that in Unreal more. Yeah, anyway, thank you so much for the raid. It's always amazing to see you all here. Thank you so much. Let me show you what we've been doing. The past 2 weeks, we've been creating this cool bridge as well. Yeah, I'll take some time off, don't worry. We'll be right back to you people with what we were learning together. Okay, so I will of course appreciate a follow because we're just starting with this whole thing if you are interested in the type of content we're making. So before we did this type of bridge that procedurally generates and creates, thank you for the follow, I appreciate it, that generates over the wait, let's kind of load a little bit. So if we have 2 points that generates this bridge. So point 1, if we put that point there, we move it there, it's gonna load a little bit, and it should basically procedurally generate the bridge there. Here we go. It can be shorter. Let's put this here, and it could be longer. And guess what? We've also added some simulation on it as well, so it will be bouncing and things like that. And guess what? This all happens in Unreal as well, so I will also show you that for the sake of presentation. Why not? I don't get rated every day, right, from White Panther, so I appreciate it. Simply test the DGA. What is it? We wanted to test if we hook a box here, what type of result we would get it, because so far we have got, okay, so I'm gonna hit escape because it's rendering a lot. I don't want it to cook yet. I think it's done with that. Good. So let's go inside of our HDA. Let's check our switch logic if it is correct. So let's hook the curve again inside of here and see exactly, that's exactly the result we wanted. All right, so I was explaining before the raid started, I was explaining that inside of the switch here, this switch, we had, now let's see, inside of that switch. Okay, so we've added an element that says whatever is coming from input 1, I will check if it has at least 1 equals to 1 number of primitives. So a number of primitives 1 Okay, so it is like a security guard that is checking, is this thing, let's make a security guard. I'm supposed to be an artist, damn it. So it's doing the stop sign. You shall not pass. Is it doing a stop sign or is it just dividing? So if there is a line, a curve, which normally has, oh my god, my typing skills, which normally has one primitive only, PR for primitive, it's checking that, and once it's basically read, so the switch is here, if it read that it has one primitive, it stops the connection and it tells it, yo, you need to be processed. We can't eat you the way you are right now. We need to process you. And if it was a cube has normally 6 primitives, or any mesh, any polygon has way more than one primitive. So a cube normally has 6 PR. Then the security guard is like happy and is like, no problem, this way. All right, so this is for my own understanding. All right, no, that's a middle finger. We don't want that. Okay, I just deleted everything. Good, we have it, we understand it. If it's checking if there's a primitive and it's allowing it, it's checking if it's a curve or not, if it's a polygon or not, and it's allowing it or not allowing it, because it's like, you need to be processed, and it goes through this whole thing, and then it gives us this thing. And what is that whole thing? Let's just go through it again. It is a normal curve first. It starts with a normal curve, then it goes into a resample. So it has one equal point numbers. So here, like between the space of it all. So 0, 1, 2, 3, etc. Then it goes, because before it was like a billion, like a lot of freaking points. And now we have like equal points. Then we run it through a smooth, so the curve is smoother. Then we run it into a sweep, so we basically create this thing on it. Now remove the points. Then we have an object merge that is basically our main object, is either a wall or like the actual mesh we want to have. Now for now it's just a cube, it's a wall. It could be a statue, it could be anything. And then we add a boolean to it, so we only get the intersection, and then it becomes this null, so it gets out. So we will just call this processed. Hopefully I spell it right. Processed noodle, process curve. Okay, good. So this is the process curve, and here it would, I mean, this naming is completely wrong. If it was a primitive, that is completely wrong. Oh, thank you for the follow, I appreciate it. So this is not if it was a primitive. This one should be checking for, nah, that is not completely right, because the switch is the ones checking if it's okay. So let's call the switch if, let's keep its name, switch if checking for curves. All right, so that is fine, checking for curves. And I will add a note here just for my own understanding. So I think it's alt n for that. No, it's completely not alt n, it seems. So I'll add a note, not a note. We'll add in that note that, yo, what's up? That switch is checking if the input, is, I don't look at the keyboard, that's why I'm getting this. If the input is a curve or not. That's too small. Okay. And if it is a curve, I'm just gonna put between brackets, meaning one prim, then not them, then it would send it to process. Awesome. Okay. If it's a mesh equals, which is brackets, which means more than one primitive, right? Here we go. More than one primitive, then it shall pass. Then it shall pass. All right. So far, so good. Let's keep that, and we're learning from it. Good stuff. Yeah, that is our switch, and that is what our switch is doing. Pretty cool stuff. Now we understand what it's doing finally, because before I was like, huh? Why do we need that? Huh? So now the other switch. Okay, let's check that switch. That switch is working with something called spare input. Spare input you could add by clicking on the setting button and then add a new spare input, like add spare input right there. The spare input we needed because we needed a couple of things before they're processed or before they go into the switch if. We needed to determine what type of polygon, what type of primitive, what type of curve, is it not curve, what type of thing is hooked here before it goes into process. Because if there is no need for it to process, then already we don't need it to process, because if we allow it to process while it doesn't need to process, it will waste a lot of resources. So a lot of processing resources, and we don't need that. So basically, we added a spare input while we still hooked everything into those two inputs, because if and only if this thing, this input here is a mesh, then we basically just need it to go afterwards, right there. And right now it's a curve. That's why it's going through this input right there, this one here. But if it was, for example, the box instead of the curve, and we will hook that here. We are hierarchy above here, by the way, on the second monitor, or on the second thing. Then it would just let it through. So how is it doing that calculation? How is that possible? If we go into the switch if, we read through the node, we see that we have use second input if. What is the second input? That is the second input. First input is here, and second input is here. And here we said, yo, only use it if all conditions are false. So you have a bool, right? You have either correct or wrong, 0 or 1. So fine. Only use the second input if all the results returning are wrong. So okay, nice. What does that mean? Here we see that it's doing its test, its if test on the spare input. So it's not doing it on the first input. It's not doing it on the second input, so it's not doing it here or here, which it would usually do. It's doing it through the spare input. Why? The same reason we mentioned before. We need to determine if this is a mesh or not early on. We don't need anything to process. Good. So now what is the test? What the hell is the test is it doing? So now, right now, it's doing the following. If the spare input has number of points equals to 0, then it should go through the second input. Wait a second. Now, if it is not, that's why we said all conditions false. Okay, so now I get it better. If it is not equal to 0, so that means if there are some points, then go through basically, yeah, use second input. Okay, so it uses the second input. But if it was, for example, not having any type of connection in our fraction region, so for example, sometimes we don't have a fraction region, we just want everything to break, so we delete that, and now it's basically going through the first input. So we're basically adding ways to make this thing work regardless of fraction input or non-fraction input. And we're doing it through counting the points. What are the points? Well, the points are those. So if I view only this here, we're doing the process right before it. And let's go into the points number. Yeah, we have all the way to 50 points, 58 points. So it's basically calculating the whole time. Does this have any points? If yes, please do the processing. Go to this input, the second one. If not, then just take the mesh, whatever mesh that is, box, column, church, whatever, right? You name it. So now we get it a bit better, or at least I do. Good. So far, so good. Then we have the null here. Amazing. We have a curve connected. Let's close this here. And what I will do now, the boring part, as usual, go back to learn some more. Just to check the rest of our node here. We have an ISO offset right after that, which should basically measure the volume of that area. Then it should scatter points inside of this area. Here they are. Then once those points that are scattering inside of those areas, they will go into a Voronoi fracture. The Voronoi fracture should split those points for us. And we can see it here in the wireframe. First of all, allow me to have the flat wire shaded view. All right. And so what we've done so far in this whole shenanigan is that we have added a fracture region, the region that should be fractured, right? So it fractured that region inside of here, but not the entire wall. That is what our system here is doing. It's doing it now with a curve. That is what we have established now so far. Then we have all our operations that actually do the variation for the scatter. And for now, they're set to basic, if I'm not mistaken. It will take some time. Basic, what is it set to? Let me go back to our parameters here. And it's set to medium, actually. Medium, here you go. Now we have the results. It had to bake a little bit, but where they are set to medium. All right, now we're having huge bake. Nah, don't go so far yet, because not everything is working yet. And so this thing goes into the switch, into the pack. And how does that look like? We see that we have issues with our fracture style here, because we have points that are not connected here. But at the same time, we have pretty good connected points here. So let me add an exploded view to show us what this thing can do. Yeah, here it is. This will be our wall that will be affected by bullets, so to speak. And right now, it's not completely working. Not entirely, I would say. But if I switch this back to our... Oh, man. I don't want to keep switching. Can I switch here? Amazing. Good. So if I switch back here, this should actually shatter it and explode it in a very equal way, which is something we don't want, really. It looks like a mouth. It's cool. Yeah, we don't want that yet. Let's check the first one, the second one, the second type of, the third type of fraction. Is it better? It should be our one that is still in testing. Hey, thank you for the following. GD does dev. Absolutely. Thank you so much. Yeah, now we still have to work on this type of things. It works pretty well for a cube. But the moment we have added a shape to this thing, it didn't work anymore. So if I add a box here, again, just to show you how this looked like before, and I go here. So our box, I will hook right now right into the auto UV. And just to show you how would that look like with the shattering, it will probably do a different effect since we have that type of fracture working right now, which is happening right there. I think this won't work with it. That's interesting. It had broke a lot of stuff. Funny, although it shouldn't. So I wonder why that is. Ah, wait, here it is. Now I get it. All right. We see that this was connected as well onto the draw curve, and now we don't have a draw curve anymore, so we need to draw another curve. All right, that's too much now. Let's just go like this. And this should take us to the switch here. Whoa, what the hell is that? Ah, I think it drew two curves, right? Yeah, definitely. But is that now thinking it's a primitive, right? So it's not processing it. So because it has two curves, let's. I'm wondering how to delete the curve because I don't know yet how to make that happen. It should be here to reset the thing. Projection, no, it's not a stroke. We have 2 strokes, so how is that? Just hover over it with the middle mouse button. We have 2 primitives indeed. That is why we are not getting any results anymore. Well, to hell with that. What we will do is Ctrl Z until we don't have 2 primitives. And what I will do now is take our box here instead of our curve, which should allow us to have some type of fraction again into the exploded view. Here it is. And now I just wanted to show you what type of fraction we have here. And so we'll start from here again. You see that? So basically what we could do, what this enables us to do, I'm just going to view this as I click into our parameters, sorry. We can add more scatter amount, which should give us more fractions. So if I put the division number from 150 to 1000, it should have 1000 pieces. Now after it loads right there, we have literally 1000 pieces. Well, not literally, but in some figurative way we have more fractions, let's say. Okay, because there's a lot of processing that is happening here. You can see some of them are merged together. We did some stuff to make them less problematic. Let's go with the medium performance. Let's see how that looks like, that style. I really like that style. It's very, very random. Yeah, for now, we get how the structure is working, at least a little bit. What I will do is delete that box now, connect our old box inside, and check if the curve works again. This will load a little bit. We'll probably press ESC so it doesn't render every little thing that we don't need that. Okay, so let's see. We're still seeing the box. We probably need to go somewhere else with our, yeah, here we go. Oh, damn, that's kind of cool. Box explode. Yeah, that's pretty cool. I think that's due to the scatter. We've added more scatter, and that basically added more fractions. Yeah, basically. All right, so what we will do is go back to our 200, because this is taking a whole long time. Press ESC, because it will process otherwise. I don't want it to process. So 200 for now. That should do the job to understand what's happening. And as for style, we'll stick with basic. So yeah, I'll press escape again and simple and escape again. And here we are. Okay, let's check it. It is working like it did before. That is what we're doing. Okay, so let's learn some more. Let's check this out. So basically so far, this thing is doing well. All right, so we left off at here. Then we went through the processing and the fracture. We explained what that means. Then we have those operations. Let's split the things and have different styles. But for now, it's just going with the fracture, basic style. Exploded view. All right, so far so good. Let's go back into learning. Needed to check before and just see the functionality of the whole thing. So what I will do is I'll go back to our exploded view and just give it a slight explosion, right? And what I also wanted to do is now add another curve to this. So let's view the actual thing and let's clear our stroke. This is how you do it. You add a clear here. All right, and now we cleared it. And let's add a different collision type, something that looks like a spiral maybe. Like this, and it goes out from here. And if I click on exploded, no, now we see that it basically made, yeah, because of the spiral, I think that had created a lot of stuff. So let's just keep it simple. Let's just do this upwards, right? And see what it does. Here it goes. It's fracturing the upper region. It's like a hammer smashing here, right? Good. Yeah, the thing is working so far. Good. That's just a way to test our ways. Let's clear it again and actually add a new one. The same shape from before. Okay, let's do something new maybe. Okay, let's go to exploded view. This looks good. Now we will basically continue learning new things. We'll be right back. So we obviously were having issues with the actual fraction styles. So if I go back into our HDA and go to the parameters and just check a different type of fraction detail type. I call it style, fine. Let's go with our medium performance because that one we have optimized a little bit. So that is going to happen, and then I'll press ESC so it doesn't process too much and cook everything. Then we will then we will click here, and we see those artifacts that we basically don't desire. So how to fix that? Let's go inside of our medium style, which is right here. Well, we have a subnetwork that actually generates the cutting plates. I think the problem lays right inside of here. If not, then it's in the operation boolean fracture. For now, let's double click on our gen cutting plates that we created today. Nah, actually yesterday. And basically we'll go through it one by one. So the split has actually split our insides. So from the fracture node, from the, what is it called? Fracture. Let's go back to it. The Voronoi fracture, which had just generated the splits. And then now inside of our generation cut, we split the inside part, not the outside part. I could also split the outside part, not the inside part, but we won't see anything because it's literally just splitting the outside part. So we'll just split the inside part. And this is just the insides of our cuts. Okay. And now we just added a null just to differentiate things, because with the split it's a bit hard to see things. Then we've added a fuse to delete the in-between faces. Then we did some cleaning. It's too much details to go through this. Divide, remesh, and a mountain to add noise. That won't help. Then we go to the operation boolean. Then here we have basically started our scaling stuff. Okay. The bound should basically take our the size from our box, which should be the mesh. Let me see the bound itself. Yeah, it's taking the same cube, the same wall, so to speak, and it's adding padding on it. So lower padding. So if this was in the x-axis 10, we will see that we'll add so much into it. We did that yesterday. And then we've added a match size node, yeah, to basically make our fractions match the size. If I see the null before that, null is just an empty node. We will see that it's actually smaller than this. So it's scaling everything up. Why? Because we need those cuts to be bigger than the wall itself. And the wall itself is here. Let's add a null here, call it mesh. Just gonna call it mesh so I don't lose track, because it could change. It could be a sphere, it could be a statue, it could be anything. All right, so this mesh is going right into the connectivity. Fine, then it's going into a compile to make things faster, then into for each connected pieces loop that takes each and every polygon here. And now I'm wondering if we should have taken our mesh. I think we need to restart this because it is, yeah, reset cached pass, and now we should have the new because it cached it through the compile. I think I could be wrong, and now it is taking the information from the actual wall. And if I just check here, this had inflated the actual wall, and this will follow along its course now. Then we converted the VDB, which is an operation, to a mesh again. So this one before was a VDB, something called VDB reshape, and the one before it's called VDB from polygon. So it's creating this VDB operation, which I think it creates planes everywhere if you zoom in at it. Yeah, it's an interesting way to add geometry. Then we inflated those. Then we basically rebaked it into a mesh. And it looks like this. Then we've taken that and created a group called cutter inside, because what we've done is we selected the points of our, here it is, of our cutters that had matched the size now of the bigger size. We created a group that selected what is on the inside of our convert from the VDB, and that had allowed us now to blast whatever is not inside. Whatever is not inside. So basically everything that was on the outside now is cut. Then after that we've allowed our Boolean operation to happen. We still have the problem. And what I've learned now from the workshop is because when we have our bound on, let me check where it is. In the match size, if we have scale to fit, and I will view our Boolean fracture. Actually, what is better to view here? Is it the group? In reference to this, maybe? Or maybe just the group itself. So if I click here and y'all gonna see the points that we selected, you see that it is not as thick. It's still inside the wall, and we needed it to scale tremendously, not only inside of here. So let's see what the match size does if we disconnect the scale to fit, or the uniform scale, sorry. Now it's on best fit. Let's see, uniform scale out, and here we go. That is the type of result we need, even though it looks very shady, like it's not gonna work. But if I go to the Boolean, and now that we changed the match size, we're getting the cuts that we would like to have. Yeah, that's awesome. So let's check our exploded view just for the test. It's awesome. Look, guys, this is so cool. This is awesome. Boosh. That's amazing. I love this. We could hook it up to like some music elements, maybe the bass or something, and just have it dance like that. Yeah, it's cool. Let's save it. Fine. Output, go inside. Let's check how it looks like inside of our exploded view as well. Looks neat. Let's do the same fix in our experimental slices that have a different style. What we'll do is enable them. Actually, we don't need to. So this is how the slices got born, so to speak. We have the same operation: fuse, clean, divide, remesh, mount, and mountain for the noise. I keep saying news for the noise. Then we have our bound and match size. The match size now needs this thing out. So uniform scale, please don't, and this should make it bigger. Yes, good. Let's check our exploded view and hook this thing here. Checky. All right. Ooh, hello there. This looks really cool. Yeah, it's definitely a whole different style. I really like this one. I think I would spend more time into this one. Like space. Cool. Awesome. Now let's check the rest of the workshop for week 3. Let's see what else is there. Problem for ourselves. And the problem is down the line. Once the whole thing had packed, so our geometry had packed, because before it was how many primitives? Let's see. So 22,000 primitives and 20,555 points. If I pack those, they become 12, 12, 12. So basically we're packing them to become so we could basically either group them easier without having problems with primitives and other stuff with the numbers, basically. So what we're doing here is that we are grouping whatever is inside the bounding region. So let me show you. If this was a geometry, so if it was a box instead of a curve, now we will wait. We see that box is actually resonating here. I will just move it a bit. Oops. I don't know what I did there, but I don't want to do it. Okay, it's not a big deal. Yeah, let's put this thing here. And let's check our group again. And we see that it selected this area. What does that mean? So every group has 2 inputs. One that has the source data, where it's taking its group from. Right now it's the pack, so it's taking from those 12 fractions, so to speak, and it's grouping them into something called bounding objects. Where are we getting our bounding objects information from? Well, it's the box. Okay, where is the box coming from? The box is coming right from the bounding object, which is hooked inside of here. So it's going from here, going inside of this null just to represent it. I'll just name it bounding object. our bounding area, because we need it to be more vague, because now it's not only a bounding object, but it also could be a bounding curve, right? So we probably need to change the connection here. And now we learn that we will also add a switch if to make this work, because well, I kind of feel like the solution would be to get the data right out of the switch if, honestly. Let's see if that would solve our problem here without adding any switch ifs, because this thing should basically fix it if I add it here. So if I have the draw curve hooked to this, we'll wait a little bit. Yeah, this should fix it. But I think it should go through some processing to make it a little bit bigger, maybe a bound and with a small scale. I don't know. This is my own creative. I'm so creative. My own like out of the box solution. Let's see what is provided in the workshop. I think it could be even smarter. And also, why is it going through a points here? Maybe because it's hooked inside of a bounding object. Let's see. Maybe there's a different solution. I'll view that and I'll be right back with you. If honestly, let's check why would we need a switch if, because I think right after that we have added the group active, which should split our active basically, and it should unpack it and then take it to a UV random, which we created the other day, and it should split. It's working for us without a switch if. It is working. And then we have an active split, which should take the active part. We have our inactive part, which should be solid and not move. Then we have our create collision, which had enabled Houdini to communicate with Unreal and create collisions as such. Good. And we also... we have the Houdini to Unreal logic that we worked on 2 days ago, I remember. Merge. Yeah, and the merge is weird, but that is fine. But then we have an exploded view, which should work. Yeah. So everything is basically fine. It should work. Let's put that into Unreal, people. Let's see if it's gonna actually work. So right click and save the node type. All right, so... whew, now it's the moment of truth. I'm really nervous. Where is our Unreal? Right there. Okay. Oh, it's gonna be interesting. Okay. I think we need to hook a couple of things for this to work. I don't think it's gonna work right out of the box, so we'll try to make it work on our own. I don't get why he added the switch if basically right after the... he added the... what he did is he copied that group, he copied the split. No, sorry. He copied the grouping here and added a switch if in between here. But I really don't know why, because this is basically working both ways. So we will see, I guess. All right, so this got rebuilt. What I would like it to do is have the actual input. Now I'm going so much outside of the comfort zone of the course. Yeah, we have 2 inputs. This thing is not working properly. This is not good. I think this might be the reason why he added the switch if, honestly. Those 2 children here, that's a problem. Maybe we could rebuild it again, but I think it's gonna crash. Well, if it crashes, it crashes, right? So it's fine. It's kind of fine. It shattered. This is looking good. Okay, let's do it again. Let's stop. And the session stopped because we added the simulation. So now what we will do is hook our curve. So right now it's using a geometry or fraction region. You see it right there. It's using a world input of that cube right there, which we hid for now. And it's fracturing it inside of here. That's why that part is fracturing and not the other part. We will change that to curve. Let's see how that would work. I'm very, very, very scared from this one here. Let's see, because it crashed before. Let's delete clear selection. Let's hide the cube again. And now we have this thing. It will bake again, but we will just continue regardless. Let's go with curve input instead. It's going to load, and it's going to be a pain to work with. All right, so here we have a curve, but that curve is not respecting the bounds of the box, so that's going to be a problem. I wonder how that's set up. Let's add another curve. This could help now. Oh, no, that is actually not helping. Control Z. Might crash right now, honestly. It might crash on us. Yeah, that is not working, definitely. Okay, fine. Let's keep following the course. I'm not entirely sure why the switch if got created, but what I could do is relook into it and risk a bit of silence, but it's fine. I mean, it is what it is. All right, so let's go and learn a couple of. Here's what happened. In his case, he basically took that switch, so the switch if from the region, and I will actually give it a name. Switch if checks if there is if the connected. This is it's gonna be a bit long. We'll take the name from inside of here. What did we call this? If checking for curves. That's good. Let's go backwards and rename this one checking. Instead of checking for curves, it's actually checking for meshes, and the naming convention is completely effed. Checking for so it's checking if there is one point, and then if there are checking for bounding input, basically, because it doesn't want to waste time. Input. Okay, so what he did, he took that thing, copied it, put it downward here, but what I did is I basically just connected it right after this null. So I took whatever output it had and just connected it. He had a whole like thing where he copied it and had two grouping, and I don't know why he did that, but like this should work too, because we already are switching our if up there. Okay, let's see how we should be able to put this into Unreal and if it would work. So I just need to learn how the geometry works to bound things with the curves. So yeah, we're just gonna check that out. Reason why this thing is taking so long, if I go inside here, this value is a bit too big for the VDB from polygons, which is also doing the same value. It's taking a bit too exact. Like if this was 0.008, it's taking it really exact into like how the shape looks like, but we don't need so much realism, right? So we'll go with something with like 0.1. Check how that looks like. That's a bit too vague. See, we don't need it to lose shape. We just kind of need it to be correct. All right, that's the value we had. So we'll just go with something a bit higher with 4. Then go to the next one, which should convert it into a mesh. And then the next one, which is convert dex composition, should give us the actual, how to say, that is the actual collision that we'll use in Unreal Engine. I think that one can be changed only by changing the value here. And that is why it was a bit faster now. So if I put that value just for the sake of learning, 0.5, the convex decomposition will take longer time because it is calculating each and every polygon that got converted. I believe this is why this is taking a long time. Okay, so we'll add escape because I don't want that operation to complete. Spamming escape until it, yeah. All right, so I hope I haven't sacrificed my mic quality because of all this operation that happened right now. So we'll put it back to 4. Oh, the mouse fell. Well, that's fun. Let's check it out. Is my mic still working? Yeah, mic is still working. Good. And okay, yeah, that is our solution for now. This should work. Before it was definitely struggling. So this will be our collision. Good. Let's see its output here. And yeah, we have a nice output. Let's go one back and we will learn a little bit more. So I'll pause. Just learned a new trick. So basically, you see this thing here, this collision, and we have to see it now in the output all the time. It's exhausting, and we don't need it to view things. Like, this is ruining the HDA for us, but we need it. Why? We need this thing in Unreal. We need it to be in this way. We need to merge it as is, and there's no way around it. But how to view this thing now in Houdini without it? Because we need to keep working on this, and it will be counterproductive to keep working on this the way we are working on it right now. So the way to do it is to duplicate the output. It's gonna take some time. Fine. Disconnect it for now. And go inside of it, and instead of 0, you just add -1. So it's adding an inside of this node output, so that only that node can read it, and we will hook it up with a proper explode view. So we'll just make a little reference out of that. So actions, and actually go to create reference copy right there. Delete that connection because we need it to happen before the merge. Where does the merge happen? Before the merge, we'll go just and pull it from the UV thing, UV random, because it has both inputs. So that is fine now. If we check our output here, it's actually showing it without the what is it called? This thing, the collision. But if we click on it in a hierarchy above, it will still show the normal output. So how do we program this thing to show the output 1? -1, of course. So yeah, let's go into that. We'll go, sorry, no, not here. Let's go right click on it, type properties, and we have seen so far the basic, the parameters, the input output, but we haven't yet checked the scripts. And the scripts, we basically have to add a new script now. And yeah, we can't know the actual script from our head. So we have to basically create a new one. And so we'll just create a normal, I think an onCreate. Yeah, onCreated. So that script will happen while so the time we click it, it will happen. And I'll try to explain my best because this is just a copy paste type of expression from Google. Just Googled basically how, we didn't Google it, but I think the mentor Googled it, how to do it, and basically explained it to us what happened there. So for now, it will be key W for keyword and args for arguments. So keyword arguments. And now it's expecting an argument. And so we need a column, the bracket, sorry. And we will basically add a node. So because this type of argument will happen in the node itself. And we'll add a dot. I don't know why. And we will basically, actually with the dot will be right there, right after this. So the node name, I think this could mean, so the actual node right now, which is DGA drawsphere, but we didn't write the name of the node, we just wrote node. Set output, so now we're setting the output for view, I would like, logic doesn't need the, for view flag. And now we'll add the -1, and that will be here, -1 right here. So what we did is we added an argument, and that argument took the current node, and we have set the output for view flag -1. And this should basically now, every time we click, let's hope it worked, accept, it will load a little bit. Let's see. And maybe I missed a couple of, maybe I had some spelling problems. Let's check if this is -1. It is. Maybe I had a spelling thing. So let's check it out. Type properties. And let's go through the actual, all right. So yeah, space issue here. No spacing. All right, so apply. and accept. And this should hopefully fix it for us. Let's check it out. We'll just wait a little bit. Okay. Didn't care to check the rest of the stuff. So yeah. Okay. Let's. Oh wait. Whoa. No. Okay. So it didn't work. Again, type properties. Let's check every single spelling and compare it to the actual spelling. Key W, args for arguments, and brackets. Is that right? Yeah, brackets with, yeah, this is correct. Dot, set, normal s, small s, output, big O, yeah, output, for f big or, okay, vu, v big, flag, f big, minus. So maybe we need a semicolon at the end. Let's just check if that's the case. Let's check if that's the case, because he didn't yet save it. So step by step and try to understand. We are 2 minutes in. We might have to go back and check other things. So what we're doing right now, I canceled, by the way, I canceled the script. It didn't work for me. I think it could be a Houdini version type of thing. So yeah, I just basically canceled that. Now let's see from before here, what type of stuff did we do? And just checking right now again, because I have not yet. All right, so our mesh, right? This mesh. Now we will do some stuff with it. We will unionize its scaling. We'll do that using match size in different operations. So let's do this. Let's add a match size. And this match size will go right inside of here, and we'll make those things go inside of it. Wait, let's add another null, call it so mesh size, right, mesh scale in. So it goes in here, then it gets processed out, just for the sake of organization. Scale out, and then we hook this in here, take all the inputs here, plus this one, hook them inside of the out. Now it will look a bit different, not a problem though. A, and click and drag down to make it fit. Okay, so the match size needs a bit of adjusting here. Let me just view the match size itself in comparison to it from before. Right now it's going in the center. We will probably use scale to fit. Okay, and this should basically give us a unionized scale to work with, but not forever. We will need to apply that now on different outputs as well. So before I continue to that, so that is the attribute we needed to add. The good thing I checked, because we need this to have the value x form, the attribute x form. That attribute is in the detail level, and it is right there. So this x form is basically telling Houdini, I suppose, the vector value, the vector4 value of, whoa, almost all the points, I think. But I can't see it now, all of it all together, because it's too big. But yeah, that is our X form. We will use that X form now in different operations. So first we need an object merge, and we need that object to be here. And let's cut that and put it inside of, we don't need that anymore, I suppose. Oh, well, let's use the thing in generate smart region right there. The generate smart region should give us the ability to use this operation, and we'll come back to you to understand why would we need that and try to reflect on what we are learning right now. Okay, so I'm in a bit of a doubt if we need to watch this video, but we'll do so regardless. Okay, so we have our object merge, and it has this thing that is wrong right now. So we need dot dot slash because we're in another hierarchy. We will basically now take the... it's a bit confusing. Let me just go backwards a bit. We will take that object merge and put it inside of a attribute transfer. And I'm trying to understand it a little bit better. Okay, so let's get null. Hook things to it right there. This will be called in region. All right. And before that happens, we need the object merge to basically go into an attribute transform. And then we'll use the X-form. We'll see how that will affect the rest of the curves and everything else. All right, attribute transfer. Put this one on the left, which should be our geometry to transfer attributes to. And this will be the geometry to transfer attribute from. And we want to change, we want to transform our detail everything basically. And right after the attribute transfer, there will be a transform attribute. Transform attribute. So this should scale things if we give it the right data. And it's taking the X form. It is scaling it indeed. Let's check in reference. Yeah, that is basically we're trying to uniform our scale, so we don't run into different issues down the line if we have to apply like different meshes. So that makes sense now a bit. We'll just make this, call it match size, match scale. Actually, it's called match size uniform. Let's call it like this. Let's give it a... All right, that's fine for now. It's good. For sure. All right, so attribute transfer, and then it's taking the transform attribute of the X form, and it's taking it to the region. It should look like this, and then output switch. Let's check our switch. What is it doing? There's definitely more to work with here, I think, because our... Where is it getting this value from? All right, let's see what else we can do. We'll be right back with you. Okay, so this is happening due to the connection here, actually. So object merge, this one is taking the merge. It's actually taking the scale from the upper level, and we don't want that. We need that to happen again from this uniform scale. And this is why we were getting that issue from. So let's hook that up in the Boolean instead of this and delete it. And this should give us the result that we desired. Exactly. And we should actually even have the sweep operation, the actual radius here hooked to some type of parameter. So we could actually control it as we go. So if we draw the curve, we should be able to enable it as we go. So right click, type properties. Let's add a parameter right there, and we can add that one quite easily by basically click on the sweep and alt click on the radius. This should, alt middle click on the radius should put it here. And yeah, let's keep it in the radius for now. Just keep it called radius because we're gonna change it later for sure. And yeah, let's keep learning. Okay, so he added a little bit of functionality, and that is through copying the Boolean itself into the region here. And now it basically takes the size, the uniformed size, and it's doing the intersection as well as on the part where it checks if there's more than one primitive, which works with a cube. And this should basically work with the same scaling, with a new type of scaling. I wonder if it was bypass, how it would have looked like. But for now, this is actually quite smart. But I'm not sure if it had broke some stuff, honestly. It's an interesting way, nevertheless. It's, I think, taking the scale down to its normal values. But let's see if it actually is working with the rest of the stuff. So let's check out our output here. Is it working with the region? Doesn't seem like it is. The unpack is here. The group active is here. Maybe it is working because we... All right, I'm just not going to go too much deep into it because I still have a lot of videos to check. So let's pause his step right now. He basically added he has added a bound. So padding basically in here. But this one should add padding, right? Or was it, what does this thing do other than adding padding? What does the bound thing do generally? There's one way to understand, let's to go to help here. So we'll open a new menu, which is like a browser menu, and it will allow us to read through the actual geometry node here. We can see it's a geometry node. Let's zoom in a little bit. You can use the bounding box with lattice node to create deforming cage for the input geometry, parameters, group type, keep original, create bounding geometry. Toggles whether the bounding geometry is created. Disabling this can be useful to record only radii or attribute, or transform attribute to the original geometry, to, for example, to use for transform by attribute, which we used. What else is there? Create when bounds empty, bounding type, blah blah blah. Well, we know that it has something to do with, I mean, one way to view what happened is to just keep a template and basically go to the boolean now, bypass it, and just try to understand. Okay, so the bound had disabled the UV for this thing? What? Why would it do that? I don't get it. I'll keep it here just for the functionality for later. Maybe we have to do it and see things are breaking apart, so we'll just keep it here. See if we are running through similar issues with our meshes. So basically we would like to, okay, let's pull this thing up and start playing with our parameters here and see if we are having the same issues with the actual explosion and the actual splitting of things. Okay. Why is this so weird though? It is definitely taking our Gen Smart. What happens if I enable this thing just for the sake of viewing this? Don't know. Okay, so let's go into the draw curve just because I wanna continue here. Okay, so it's going like this. All right, fine by me. Let's stack our switch check. Actually, let's go to our fraction, to Vernoid fracture. View that. All right, so that's good. Things are working here. Let's see right after the explosion here. Which size? Yeah, we are having issues, definitely. Like here we see it. All right, so let's see how to fix those issues. We'll go one by one. Which style are we choosing? The good one. All right, so let's go into our generate plates. We will go first of all into the all right, so what we will do is make it go bigger, even bigger than the whole thing. So we'll add a transform centroid. Transform centroid, or transform from centroid. We will add it right before the remesh, and this will allow us now to go on the scale a bit bigger, right, like this. And right after that, we'll go into the remesh here. And what we notice about our bars here, if I go back to our parameters with ASC, all right, and I just choose this mesh here. We look at our remesher, and if I go big in the value here, we almost don't have any detail anymore. And one way to soften that effect is to go into the connection. So click here. Oh, sorry, Ctrl Z. Click here and just add a division of 5 or of 10, for example. This will make it softer, which will allow us now to take the remesher and basically play with it in a smoother way. Let's escape anything it's trying to do right now. Okay, and now we will remesh. You see, we could see what we're doing, right? Much better, basically. So if I show you the wireframe, we can play with our values now a bit better. The same thing we will do on the rest of the things here, especially, so in the here, press W, especially in our mountain here, we have a value for the element size and a value for the amplitude. These are quite extreme because if I take the amplitude right now, view it, and I take the amplitude and play with it a little bit, boom, it's already inflating and doing all types of stuff. So let's basically divide that by 10. And now if I play with it, you see we have a bit of margin of failure, basically. I would like it to be actually a bit more divided because I would love to play with this a bit more going on. Or, you know, going forward, not going on, going forward. And in the element size, this is the actual texture size. And if I view it to you here right now, it's super reactive. And I would like it to be less reactive and maybe go with something like 20 again. So just that we have that control with the bar and we could actually like add something logical to it. And the amplitude needs to chill now. All right, and some more amplitude, some more noise texture, just so we don't run into those issues again. Okay, good. Now this goes into the output. Let's go a little bit backwards. Check our switch here to see if we are still getting those fractures. Not much. I mean, we still have this problem here, and I think we could fix in the next level, which is the operation boolean. Let's go to the operation boolean and check our bound, which had added the padding, and the bound is here, the match size is here. I think we need to update that with the actual sizing. Could that be true? I think we need to, otherwise. All right, let's try to do that. So let's go back here, get our merge object, this one, our object merge, go backwards, go inside of our solution for the operation boolean, and put that thing. So wait, does it already have it? I think it does. It already had the value, so we don't need to introduce it here. Okay, that's good. So it is already updated. Just one more thing though. How far deep is this going, and how do we want it to look like? When I go into the output here as a reference, what are we getting? This is way too big. The thing needs to chill. But I think that is due to the transform centroid we've added. Okay, let's check how to fix this. All right, so I'll try to problem solve this thing. I'm not entirely sure why this happened. I will just go through their project now and go to the same points. Generate shell, blah, blah, blah. We haven't gone that far yet. Clean mesh. The alter UV, blah, blah, blah. Let's see. It must be there. Mesh size, switch, in-scaled mesh, transform. This is all. Oh, we don't need that. Connectivity. Detail fracture. Is that the one? Let's zoom in. Let's see our fracture node. Is that the one? Yeah, that's the one creating those things. Let's go down there. Object merge, group, blah, blah, blah. Where is the cut happening? Detail fracture must be right there. Okay, so if I go inside of here, we have vernoid fracture, we have generate cutters, we have Boolean fracture, we have merge small parts. All right, so we're going into it now one by one. So generate cutters, that is the one we need to check. All right, and here they've added transform from centroid, and that one is 2. Okay, but how the hell is it coming back to what it was before. So it is exploding in that way. It's adding a mountain and then it's getting into the output. Then it's going into the generate cutters. Then, so the generate cutters is taking the split, the inside split. Wait, what is happening in here? All right, so we just viewed it again. All right, so Boolean fracture, that's the one. How did it go back to its size? So it went from switch create shell. Aha. Where is that from? Is it in the first here? All right, switch create shell. Let's just see what that create shell is doing. It's just creating. Where is it coming from? All the way from auto UV. Generate shell, what is that doing? I think that is something we need to look at once we add different types of meshes. But for now, yeah, it's just basically the input. Let's just respect it as that. Let's go inside of here. And we have all those fractions, right? So then we've adding the bound to them. Just what I don't understand is how does the transform of the fractures not transfer everything with it? Like, what did we do in our thing that made it look like that? There's nothing different really to what they're doing. Mine is just way too big right now. If I go inside of, where is this going? Explode view. Yeah, it's way too big. Where else is it way too big? Right after the operation, yeah, this thing is going insanely big. We don't need that. And why did we use it anyway? Let's see, generation. Yeah, how the hell is this not coming down to its normal size? And why did we scale it to begin with if it's not gonna go down? Let's bypass it for now. Check if we're getting the same issue right after the explosion, or if we can just bypass that. All right, so let's check our explosion. Yeah, we're having issues, which of course sucks, but we're having issues with the size generally because that is anyway not the actual representation of the fraction. The fracturenoid should fracture inside of here and not everywhere else. So all right, so where's this going? Let's see. It's going into the box, which shouldn't, right? It should go right out of the scale out. So we'll delete this because I'm not sure where this is connected from now anymore. So it's connected once here and again inside of here, the second input. All right, and now we will check. All right, so this thing is as well. All right, so let's check if this is proper now. Completely broken everything. Let's see our fracture, if it's still working. Fracture is working. It is going inside. It should be coming inside one of those, right? Just let me check. Yeah, it should be in the first one here. So let's do that. Fraction right here. Because we need the actual split to happen. Okay. And so this is what this is doing. Is it correct? Let me just play with the amplitude a little bit. That is way too small, y'all. Let's take the amplitude into this direction. Looks good for now. Then now this thing is taking its value from the proper one, or is it still wrong? This is the proper scale. But wait, is it anything is coming from the other thing? Match size? This is matching the size, putting it down, then it's coming inside of here. And then it's going inside. Wait, do I have it proper? Wait a second. So this is the output of this, okay? And this thing is, why is it not doing what I want it to do? What's happening? I think we need to, yeah, do the same thing here with reset. Actually, that didn't change much. What's happening in here? So this is our mesh, right? So our mesh has the correct scale. However, whatever is coming through Gen cutting plates here is big. No, it's not. But then it's coming into the match size and then it's going insane. All right, so that is a type of thing we need to fix. Let's go with 2.2 on all of those. We don't want it to go that crazy because it's ruining stuff for us. Okay, fine. Okay, how does that go now in the fracture and explodes? Okay, so let's see. Let's put, yeah, that is now it got fixed for us. Let's see what happens in the output now. Output seems to have, yeah, this looks good. Then of course it goes into delete pieces to make it a bit more friendly with the performance and everything. Good. Now what I wanted to test at the end, I want to change the size of the noise, make it more noisy maybe. Make our amplitude bigger, just to test. Yeah, the bigger we make the amplitude, the more it breaks. But I want the amplitude sometimes to be big. So what I would like to do is go into our generation of those individual blades, or plates, whatever you want to call them. Let's see if we make this bigger. How would that change things? Would they change for the better or for the worse? Let's just check our operation boolean here. Operation small pieces. All right. Does this look? Yeah. We definitely had fixed it now. I think it was taking its mesh information from the wrong null, and now we fixed it. That's perfect. It's pretty good. Let's check our explosion. And now because we made that thing so big in the centroid, transform from centroid, we have this type of effect here. Now we can take the amplitude lower just to have a different effect. Now it is, does it break? Is it really breaking? The size, yeah, now it's too big. I think the size deserve like division of 30, honestly, because this thing is way too. So let's go into the remesh, I believe. No, it's the mountain, and let's go to like division of 40, so double as much, and just change it. Yeah, that is much better, much better. Good. Amplitude, we could change that now. Perfect. And remesh adds more details. Good. That's amazing. People, that's amazing so far. I'm basically gonna wrap up the stream so far. We have done some progress. Maybe tomorrow I'm busy. Weekend is weekend. We haven't really completed the week 3. Let me just show you where we are right now. This is where we are. It's fine to show you a bit of it. It's paused anyway. So this is DoubleJump Academy course. This is basically all the structure of it. Module 1 is week 1, module 2 week 2. We completed all of those. Week 3, as you can see, we have completed until here. It's because it's a bit complex. And I was doing a lot of problem solving in the beginning of the week 3. So yeah, it is what it is. But then we will go, we have 1, 2, 3, 4, 5, 6, 7, and then we will dive into more stuff. Those are all the weeks, 8 weeks to go. If you're wondering how we came to this result so far and what happens before, I'll take you to my YouTube channel without showing you my suggestions. Just gonna take you to YouTube, to Jack the Generalist on YouTube, which is also available. Generalist, which should also be available on the links I have on my Twitch channel. All right, and this is all the days documented and cut. As you can see, this is an 8-hour stream cut to 51 minutes and so on. we started from day one with 0 installing Houdini, and we continued and over and over and over, and then now we are right here where we did the destruction and everything. If you haven't follow me now. It will help a lot. My channel is quite small still. We started with we started 5 weeks ago as I got laid off, and now we are getting bigger and we're having a bigger community, thank God. And I would like to also add the Discord that we just created. If y'all want to join, I would appreciate it, of course. I'll add it on all the platforms. So yeah, if you want to join, I would be more than happy. And yeah, we could notify you when I am live, and we could chat. We have now around 10 members. It's quite cool. Yeah, that is it for today, and y'all have a good day. And we're probably gonna rate, so we continue the tradition. So gonna rate you to someone I like if they're live. And yeah, let's do that. Let's do the rating thingy now that I finally can do rating. So let's do that. As for the people on YouTube recording this, see you later. And yeah, next time it will be on Monday, most likely.